Hello everybody and welcome to another Mystery Box Function Challenge. In this purple box there is some mystery math and your challenge is to figure out what that is. You can use the link in the description to try this out, and when you've got an idea, come on back, see if we get the same thing. Alright, let's begin. I'm going to put in a 0. Okay, so 0 gives us 3. How about a 1? 1 gives us 4. Okay, maybe this is the line f of x equals x plus 3. How about a negative 1? It's definitely looking linear, although maybe it's cubic. Let's put in a negative 2. Yeah, so this appears to be a linear function, at least so far. We should do some values further out. Let's do a negative 5. Seems to continue the pattern. How about a positive 5? Oh, okay, so that does not continue the linear pattern. So because we've got what looks like a line with a positive slope, slope of positive 1 on the left side here, and then something else going down on the right side, I'm going to guess that this is an absolute value function. Let's just try to fill in some more points over here. What I'd like to do is find the vertex, which maybe is somewhere up here. Yeah, let's do a few more points on the right. So put in a 2. And how about a 3? Does it start to go down here? Yeah, there it is. And let's fill in the 4 here just so we see the whole shape of it. Yeah, okay. So this clearly looks like an absolute value function. It's that sharp turn, that V shape. In this case, it's upside down. So when we start sketching out what this function is, that's the first thing to notice, and that means the whole thing has gotten a negative sign on the outside. And then we have to determine whether there's any kind of multiplier, and also, the basic absolute value function would have its vertex at 0, 0. That would just be absolute value of x, or negative absolute value of x. In this case, we've moved up and over. So let's talk about the slope first, though, so we know whether there needs to be a multiplier. You can tell the multiplier of an absolute value function by looking at the slope of your lines. And what we've got here is a slope of 1. Every turn it goes up 1 over 1. And then, of course, over here it's the opposite of that. It's negative 1, so down 1 over 1. When it's a slope of 1, that means there is no multiplier. This is just your basic absolute value of x. But I am going to leave space inside the absolute value brackets and outside at the end because we've clearly moved over and we moved up. I'm going to put the x in there, though. So the up part is really the easiest because it's just plus on the end. If a function's moved up, you're adding at the end. If a function's moved down, you're subtracting. We've moved up 1, 2, 3, 4, 5 from the origin or from the x-axis. So this is a plus 5. And then the over, it seems counterintuitive at first, although if you test some values, you'll see it clearly works. It's the opposite sign than you might think. We're moving 2 in a positive direction here to the right. That means you subtract 2. So that's what I think the function is. Let's put in a couple of values to see. So if we put in, well, let's put in this value right here, 2. If you put in 2, 2 minus 2 is 0. You get negative 0 plus 5. That's just going to be 5. So the vertex makes sense with this one. Let's try a 3 if we put a 3 in here. So negative absolute value of 3 minus 2 plus 5. So 3 minus 2 is 1, and then that's negative 1 plus 5. And that should be 4. So we got a 3, 4. Beautiful. Let's predict one. What do we get if we put in a 5? So negative absolute value of 5 minus 2 plus 5. 5 minus 2 is 3. Absolute value is still 3. Negative 3 then plus 5 is going to be 2. So if I put in a 5, I should get out a 2. Oh, and I did that already. Ha! So we tested another point. Well, let's put in a 6 then and do that. So I'm going to change this to be a 6. So 6 minus 2 is 4, so this would be a 4. And negative 4 plus 5 would be 1. So if we put in a 6, we should get a 1. Let's try that. And there's our 6, 1. So I think it's pretty clear we've got this one. Let's reveal it. And there it is, negative absolute value of x minus 2 plus 5. And let's graph that as well. And there's our sharp turn up there at the vertex at 2, 5. Well, how did that go for you? Were you thinking a linear function like I was? Let me know. Thanks, everybody.